This is the new Aristocraft, or new for me, train engineer, the 2.4 gigahertz Revolution version, and this is the base unit or base station I bought, which is capable of 15 amps, which is the main reason why I bought it. And they give you an optional, which I also decided to purchase, a PWC to linear board that's designed for the base station version, so presumably can handle higher current than the version of this that's meant to go inside a loco. So, and then this is the little transmitter unit. You can turn it on here by holding the button on. And right now it says no link because I don't have the power supply. In this setup I have the Ultima power supply just for the purpose of setting it up or testing it. So I'm going to turn that on, and you can see a couple of lights here come on. There's a light down near the heat sink between the input connector, and then there's an LED here that's used for linking purposes. And I also noticed that when there's a speed selection of anything other than 0, that light will come on. That LED will come on. So I've chose to label this thing track power, which you can do, and again I've programmed it for base unit. And this is the receiver board here. There's a small antenna here that you can, there's a wire you can move around, and so presumably that's the quarter wavelength, and it's supposedly a 2.4 gigahertz system, quite a change from the 27 megahertz system that I've been using. And I've got a setup here, including an ammeter and a Tektronix oscilloscope here, and a GP40 logo on Bachmann rollers, and the scope is connected across the track rails, and it's 5 volts per centimeter. You can see the pulse here. So as the pulse increases, the logo will start moving. Here's a test setup in my loft for testing the Revolution Train Engineer as a base station for track power purposes. And the principal reason why I bought it is because of the current capability. As you can see in the fuse here, it's rated at 15 amps, and at the 10 amp 27 megahertz unit, I was blowing fuses when I tried to put more than 4 locos pulling a train up my grade on my outdoor layout. So this is the new Revolution base station type train engineer, and this is the remote control handheld device. And one nice thing about it, I'm using a, by the way, a Ultima power supply for this test purpose. It puts out, it's supposed to put out 18 volts, it actually puts about at 17, maybe 16. So one nice thing about this handheld unit, it shows if linking is working. And for example, like if you're out of range, it'll say not link, which I can simulate by pushing a button down here, not link, and it's essentially testing the linking capability. So I've labeled the single unit as track power, and it's the base unit here. And I don't know if it'll show up in this video, but that tells me it's track power. And if you use these keys here, it's meant to really have receivers and other locos. Then whatever label happens to be in there for the single unit, in this case it's L-49, but I'm only using supposed or just the base station, so I call it track power, which I chose to label. So on here, this is a Tektronix 74 or 2465 oscilloscope. The ground trace is set up here. It's 5 volts per centimeter. And you'll see this little gradation vertical line here. It turns out that when I increase the throttle speed, you'll see pulses here because it's in pulse width control mode, and it'll show you a 62.62 microsecond repetition rate. So I will do that here. And oh, by the way, here's the GP40 as a test load on Bachmann rollers, and the scope is across the track. Channel A minus channel B differential. And so I will see the first step in the, or I should say the first push of the speed button on the transmitter yields a pulse that looks like this. And with that minimal amount, you can see the lights aren't on. It's supposed to be an advantage of pulse width control, but as I increase it ever so slightly, maybe decrease it here ever so slightly, and go over here and watch the lights, increase it. There, it's starting to light up. And notice the motors aren't turning the wheels yet, which is the advantage of pulse width control, for at least one of the advantages. And so if I increase the pulse width here, and I'll go over here and watch the rollers and see when it starts. There, the front truck has started. The rear truck has not. There, the rear truck started with one more push of the button. And so that's 10 microseconds per centimeter, so it looks like about 10 and a half microseconds. It looks like the motors start to move. So I'll keep increasing the speed by increasing the pulse width. And you can see the leading edge of the pulse. The leading edge of the pulse is 62.62 microseconds, and the reciprocal of that is about 16 kilohertz, close to 16 kilohertz, which is very similar to the old NTSC television horizontal rate. 15750, I think, was that rate, and sometimes people could hear that, but right now I can't hear it. There's the logo. So I'll keep increasing it. And notice the voltage down here, irrespective of increasing the pulse width, is actually slightly negative. The ground trace is right here, and it's about 1.5 volts negative, which is interesting. But it's reaching a positive level of 5, 10, 15, 16, well, close to 17 and a half, 18, close to 18, which is interesting. And that's about the limit of the ultimate power supply up there. So if I increase it more, and it almost becomes flatline. You can see a slight negative pulse here. Unlike the 27 megahertz unit I have, this unit supposedly, well, the RF part of it, they call it a 2.4 gigahertz. You can see the 2.4 on there. But the 27 megahertz actually goes to a flat line. It doesn't retain a slight negative pulse. And perhaps this is about a microsecond. So I shouldn't say negative, I should say a complementary pulse going from a plus voltage toward ground in this case. And you can see the loco is spinning away. And the ammeter I have in the setup is indicating about 1.2 amps. So now what I'm going to do is run the pulse width down. I'll just leave it about there. And now I'm going to change directions. So you can see the polarity kind of reverse here. So I should negative trigger it here. So again, the waveform, the base of the waveform looks like it's maybe a positive 1 volt, which is interesting. Now I'll increase the pulse width in this direction. And that's maximum. Again, there's a slight pulse that's going from, oh, maybe minus 17 to towards ground here, maybe about a microsecond. So it's similar to the other direction. And the ammeter is similarly 1.1, maybe 1.2 amps. And now I'll reverse direction again. Push the left key in this case. And there you have it. This is the new Aristocraft Revolution Train Engineer, the base station version, which is physically a little bit larger and is capable of 15 amp output, which is the reason why I acquired it. I have it hooked up through here, through the optional PWC to linear board, because some rolling stock doesn't work with PWC. For example, USA Train's caboose with the flashing rear light doesn't work with PWC. So for this test, I hooked up the unit, the output of the Revolution to the PWC to linear converter, and I have a setup here for test purposes. And there's an ammeter here that I can measure the current that's being delivered. And for now I'm using an Ultima power supply just for the purposes of this test. So I can turn it on and you'll see one of these lights light up here. Something called output, or there's an LED near the output that's illuminated as soon as power is applied. And this is the remote control transmitter. And you can turn it on here. You have to hold it for a short time. And what I've set it up for is I call it track power. You can enter the names of these things here that you want to do. So up here, I don't know if it's discernible with this video recording, but I've labeled it, or I named it track power, because it is the base station for that purpose. And one nice thing about it is, it has what's called the link status here. It'll say link no or link OK, as in this case. So that'll inform the user if they're connected to the from the transmitter to the receiver if there's any range problem. So what I'm doing here is I have a Aristocraft GP40 on Bachmann rollers, and I have the oscilloscope here at Tektronix 2465A connected channel A minus B across the rails here. And so if I command the speed increase, and if I change, well, first of all, I'll select the direction here, in this case supposedly the left direction, and increase the speed, or increase the voltage. And being it's linear, you can see the trace here is rising up, and it's calibrated for 5 volts per centimeter. And somewhere near 4 to 5 volts, the wheels start turning on this particular loco. And as limited by this ultimate power supply, it's supposed 10 amp capable at 18 volts. It actually is only about 15 volts on the output and a much lower current. So I'll increase the speed here up to max. So it's about 16.5 volts roughly. And there's the loco coming away. The lights are on. And the ammeter is pretty steady at about 1.2 amps. Now what I'll do is reverse. I'll lessen the voltage. And then I'll change direction here and increase the voltage. And notice the filtering doesn't seem to work in this opposite direction. This is negative direction here. You can see part of a waveform on it. It's certainly is DC, but it seems stepped. So there's the maximum speed in the other direction, and it looks to be about 16, so maybe 17 volts, minus 17 in this case. The loco is spinning away and the lights are on. And the ammeter is again about 1.2 amps. Maybe a little less, 1.1, maybe 1.2. So as I lessen the you can see part of the PWM waveform there not being filtered, and you can see where I have 62.62 microseconds up here with this trace. You can see I can align it to the repetition, and there's a dotted line on the left side here as a reference, and that's about a rate of almost 16 kilohertz. If you take the reciprocal of 62.88 or 62.62 is what I had when I was testing it before. So that's an interesting thing, but it doesn't seem to cause any problems. So that's in linear output.